Hello, this is Brynja. Welcome to my webinar about JavaScript, and let's talk more about objects. Let's start with this object stub. This is an object representing a user. Let's say I want to work with two users, not just one. I would have to somehow recreate this over and over again. So user 1, user 2, user 3. Sorry, you get it, I'm smoking. By the way, the comma after the last key per value is optional. I just like to write it. It's easier just to copy it around. If it wasn't here, there would actually be an error. Here I would have to pass it. It is actually allowed syntax in the new browsers. In old browsers, this can actually throw an error, the comma after the last value. I have this tab and I want to reuse it. Well, I can declare it again, of course, or we have functions for that. Should work perfectly. Again, it's not mandatory. The naming, usually when I have some more complex parameters, I usually write them starting with A and then every word with a capital letter. So when I look in the code, I know, okay, this is a parameter in a function. I look at it and I see, okay, this is a variable within the function. This is a parameter of the function. It starts with A. And when I have when I have like two words, I usually use what's known as camel case, which means the first word starting with the lower, any other word starting with capital. Something like this. This is known as camel case. So I have a variable identifier from 4 words. I start the first one with lower, the other one with capital. It doesn't matter, by the way. Just a convention. This is known as a camel case. I usually use noun for identifiers, and I use for identifier holding regular values, and I use verbs for functions. Get full name. Something like this. If I had this like just, I can do this of course, but since it's a function, I usually use verb get full name, or let's say set something like this. Of course I can access the first name directly, but I can create a setter, so-called setter. So I can work with that. User 1 is a John Doe with empty address. I can of course work with it. It returns an object by reference, which means whatever I said here, again it's by reference, not copying the value. So if I set the parameter first name and last name here, it gets created by reference. And I even have the building number 125. I have user 2 and Jane Smith. First name Jane, I can do user 2 first name is Janet. I can call get full name. I have Janet Smith. I can call set first name to I don't know. I cannot figure out name Eva. Get full name Eva Smith. It works as it should work. It works perfectly fine. User 1 is still John Doe, because I'm always here, I'm always creating new object. Again, when you're returning a value, you have to start on the same line, otherwise it will fail. It will insert semicolon automatically here. I use indentation for better visibility of what's going on. It's working. It's working perfectly. Is it the best way to do it? Nah, not even closely. There's gonna be a lot of people who will tell you, okay, this is a way how to create objects. This is the best way how to create objects. It's not true. Actually, I don't agree with that. I'm gonna explain why throughout the course. You make up your own mind. It's programming, it's not religion. There are no truth, undeniable truth here. If you have several options, you have to know what the options do and you have to weigh them. So, okay, I can return an object and I can work with it from a function. So I return a regular value from a function. The value is actually an object. Let's work with construction of function. So every time a function as I've said, is created, execution context is created, and this is created within the execution context. So this is available. When you call the function as a constructor, in which case I usually use Pascal casing, which means every word is capitalized, you can do it differently. So let's do it this way. Let's do it like this. Okay, it fails in a strict mode. It doesn't do what it's supposed to do. Sort of in unstrict mode. Let's stick to strict mode, so it fails actually. Because in strict mode, this is undefined. This exists, but it's undefined. What you need to do is call the construction function with the new keyword new. What does it do? The new on its own sort of creates an empty object, and it passes the object to the construction function as a this. Hey, it's working. So we have a new user. You can actually see the sort of the name of the construction function. Let's just call it the user. Because the function represents, it doesn't necessarily, the construction function isn't, I don't use a verb as doing something. I call it as an object it should represent. So this is how you do it using construction function. The result is the same, sort of, as a literal, but it's using the keyword new. So when you use the keyword new in either mode, it doesn't matter, it will still work. In a strict mode, it only checks that you actually called constructor with the word new. If you're missing the word new in a strict mode, it will complain because this doesn't exist. So as I've said, every time you start a script, you do ify. Within the ify, you do use strict. You don't put it outside. You don't put it in the global scope. This would affect other scripts as well. But this creates new execution context. It applies the strict mode to the execution, to the new execution context, and everything you write here exists in the strict mode, but only in that execution context of the ify. So everything in a code is like inside the function. So this is another way how to create an object. When you call a function with the new, empty object is created. Okay, of course there is no building here. empty object is created, again as only the proto, and it's automatically returned. There is no return statement here. There can be written this, it doesn't matter. It does that automatically. And since you can create properties on empty objects, whether they are properties or methods, you can do it on this. So this is a way, and this is another way how to define an object using a constructor function, because it constructs an object. I can technically do this. When you see the address is sort of like an object with those properties. Okay, let me put it this way. Because address is an object, I can do it this way as well. It's a constructor, it has a capital A. So it has an address, it has a type address, you can see it here. It works as it should. I can reassign to it. So address building 125. When you're working with a constructor, you don't have to do it this way. It's not necessary. It's optional. When you would work with function, this would assign the function, that would assign the result of the function. In objects, when you use the new keyword, it doesn't matter whether you sort of execute it or not, because it gets executed by the new keyword anyway. So you can do it like this. Using a constructor function. What construction functions allows you to do, let me check it out if it's gonna work, is work with what's known as privates. It's not the best way how to do it, but it's a possible way. It works with closures, and I want to show it. So let's say there is a username here, but the username should not be changeable. So if I did something like username and put this here and this here, okay, so I would have a username as well. Why is the last name capitalized? Okay, that's a lower L, it just looks like capital L. So it has a username, but I can touch it. username is different. So what if I don't want to do it? Well, I can use closures. So I can ask for user1 get username, and I cannot set it to it, but it exists because as a closure works, this function is defined with this variable, so this variable must hold in the scope. So if I call user2 with username, I would get different username. It works around with the closure, so I can technically define a value here. Let's say contact. How many times I contacted the value, the user. 0, and I can say do contact function, and I can do this and this get num of contacts is a function return contact. Okay, so let's contact this user, say 3 times. Okay, it's contacted 3 times. But I cannot go and decrease it. I have no access to this value contact. There is no access to it from outside because the variable exists within the user. How would I access it? But thanks to closure, it exists within the scope of this function. It has to, because the scope of this function is given lexically, which means this function sees what this function sees, and when I exit the function I can just discard the scope chain in the middle. I've explained it already. So this is called public. This is called public because you can access it from outside. This is called private because there is no way how to access it. I cannot decrease the contacts. I cannot go and decrease the contacts. If I had the contacts outside, contacts, let's say 0, I can do this. Oh, no, this. Of course, not this. Someone can go and and set. Okay, let's say we haven't contacted him yet. Or let's say I've contacted him 5 times, although I didn't went through the process of contacting. I didn't call the do contact method. I can change it. This is the public properties are simply available from everywhere, but you can mimic private using closures. It's not private property. I'm going to show you how to create a private property later. But this is the way how privates have been done for a very long time, because there was no other way how to create privates. Inaccessible values. There can also be sort of a private function. Change it from outside. Let's change the order and let's do it this way. Get full name do, return Fernando on this. What? Okay, there are two returns here. So user1 get full name, John Doe, get full name Doe John. Again, the function exists because this variable exists within the scope of the closure of the function. This is sort of like a private function. Again, it's not accessible from outside, because from outside it doesn't exist. But when you're calling this function, the function creates the closure around it. So this is a way how we deal with how we dealt with private states when you needed some state being inaccessible from outside. And when you're using private states, for example, for a function like doContact and get number of contacts, this is the only way how we can do it. Or it used to be the only way how you can do it. I'm showing several ways because it's important to understand how inheritance works. We're going to talk about inheritance in JavaScript, and it's important to understand how it works. So even though I wouldn't use this way necessarily, unless someone told me, okay, the application must run on Internet Explorer 8, well, you have no other way. But there is a better way for new browsers, but it is important to understand how objects actually work. So, okay. So what happens when we create this? Let me take this, put it here, maybe it's gonna be useful again. Let me do this, why not, it doesn't matter. This, we're back to working perfectly as we used to. James Doe. Perfect. What happens when you actually call this function, this constructor? Again, it has to be called with new. say there's address, there's everything like this supposed to be. So we have in a memory new object with a bunch of properties. It can be tied to another object, and then we have, of course, some sort of function. What the? Sometimes I confused by this. Let's say it does something. Do we have? Okay, it looks like a process. So let's say it's a process. It's actually a function. It's not a process. It doesn't matter. It's different. So we have a we have a value with the we have a property with with primitive value. We have property with object. We have property with functions. We have methods. So this gets created in memory. When I do this call again, another one appears in a memory, the same one. And if I call it for the third time, another one, and another one, and another one. Well, that's a lot of memory. I hate this. Okay. That's a lot of memory. Come on. Okay. That can be a lot of memory. What is interesting here is, while this usually changes because these are primitive values, although this is an object, but that object holds another primitive values, it can change. Well, this is not going to change that much. This is always going to be pretty much the same. Wouldn't be a way how to isn't there a way how to save a memory when we say all of the users is gonna have this functionality, but the properties, whether direct or through other objects, well, they can change. Especially when I do something like this. Do I have a full address? Of course I deleted it. Okay. How do I want it? Street. Let's put it into backticks. Street, building, comma, zip. empty state. Please rename the state to country. It's better. It's working. So now there would be another functions in the address, and again it would be the same function, the very same function would be attached to every single address object. So although this can change, this most likely won't change. Of course I can reassign it. I mean, why not? Nothing prevents me. And it does nothing. Usually you won't do this. You would assign the properties, the regular properties, but you wouldn't touch the functions. So can I change it so it doesn't use that much memory? And that's the point why I don't necessarily, I will get to it, to the privates, why I don't necessarily like this pattern when you define it directly on it. Well, functions are objects. I've said it. Function has a property, functions have a property called prototype. All functions have a property called prototype. We know about the number function. It turns anything into number. By anything, I mean anything, even empty object. It's a function, it has a property, prototype. It's an object. A prototype is a special property. So let's change that. Change this. User.prototype dot get full name. Let's do this. Set full name. Oh, set first name. Let's remove this. Get full address. User1 get full name John Doe. User2 get full name Jane Smith. User1 address get full address. Okay, it still works. So what does it do? How does it work? As I've said, every function has a prototype. So since user is a function, let's create it, for example, like this. This is the function user. It has some code, it's an object, it has a lot of properties. One of the property is a prototype. So that's the prototype of user. It will work the same for address. And I set the user.prototype as this. So when I create the objects, the functions don't exist on the objects. They don't. They exist on the prototype. So how can I call them? Why can I call them? Every object, when you create it, has a constructor, and it is actually the constructor function. So I can do user3 equals user1 constructor. I can do it like this. Well, it works. Let me call it with a bb. It works. It has every function has a property constructor. Or every object has a property constructor. I'm sorry, not every. Although function is an object, which means it has also by default. I didn't even create it, but it's an object. It has a property constructor. End of story. If it is constructed by a function, it has a property constructor. Well, this object doesn't have a x constructor let x equal this. It has some constructor, the constructor object. So it knows when it points, where it points. You don't have to bother with the constructor. It simply has it automatically. So when I'm asking for anything, any property from that object, it looks at the constructor and the prototype of the constructor. So when I'm asking this object for get full name, it says, okay, I don't have it, so let's check out the prototype of my constructor, and that is a get full name. It exists, and it gets called. And although, again, it's a function, and as we know, what's important for the function is the context where it's called. So although it's defined on the object that is user prototype, when I call it on a context of a user, it works. I showed it last time when I was passing around methods of objects. So you can define it in a prototype. This way, I can have as many users as I want, but only one prototype, only one constructor with one prototype, and I'm saving memory and I'm saving processing power. Time, because I don't have to create those functions every time I call a user. I have to create and I consume the memory by this, but those are fields that are most likely going to be changed. But the prototype, not necessarily. but the functions not necessarily. I can reassign still the function. What's gonna happen if I reassign the function? Okay, it does nothing. It works for Jane Smith. Why? Well, because this doesn't exist on that object. It's not. Okay, it exists in the prototype chain. User1 has own property. Okay, so this checks out the whole prototype chain. Again, it's an object. By default has a method, has own property. By default, it has that in a prototype chain. I'm going to explain inheritance later, but I'm asking it has own property full name. I can ask for first name. That's true. First name is defined on that object. Get full name is not. Again, it has this property through prototype chain of prototype of prototype of prototype. I'm gonna explain the whole prototype chain later. Apparently it does have it. It's working. So the get full name is now its own property because it's the property of the prototype. First name is the property. When you're assigning, what it does, most often, not always, there are exceptions to everything, it assigns to the property on that object. So this on that object is undefined. You can find it of course, but you can find it in a prototype. But when you assign to it, it doesn't go to the prototype, it creates it on the object itself. So now the user1 has a different version of a getFullName function. It has its own version of getFullName function. When I do this, you can see there is a getFullName directly on that object, user1. User2 has it on a prototype, getFullName. So I can overload the function still if necessary, and it won't break the other objects. So this using the prototype is actually very powerful because you're saving space, you're saving memory space, you're saving, you're saving memory space, you're saving speed, because this gets created only once, not every time you call user. So there are, as I said, there are people who's gonna tell you, okay, this is the best way how to create objects. No, because you have to define the functions, you have to define everything for every single instance of the constructor. This way you don't. It actually works with the properties as well. Let's make a property email. Let's put it here. So it doesn't have a default, but it exists. So user1 email, okay, it's empty. User2 email, it's empty. It's a property of an object. No. User1 email, user2 email. It goes through the prototype chain. It doesn't exist on a user, it exists here. So it goes through construction function prototype to the object, to the prototype object, it finds it there. When I write to it, again, it's get assigned directly to that object. I can see it directly on an object. It still exists in the prototype, but the first one I check is the object itself. On user 2, it doesn't exist on an object, so when I ask for it, it has to go to the prototype. So you can actually save a lot of space. This is pretty much the only space we can save now, because I'm passing this as a parameters and I need to set them up. There's no other way how would I set them up. But anything else that is shared, I can do this. I cannot share this because that's an object. That would cause issue. That would definitely cause an issue. Because I'm not working with the address directly. I'm working this user1 dot address dot building. Okay, it does what it's supposed to do. But user2 is the same because I'm touching the same object of address. Because I'm always going through the prototype. I'm not assigning here to the address. Of course, if I did something like this, that would work. Because I'm reassigning the property, but since I'm touching, in this case, okay, address wouldn't exist here, so let's create it here and let's touch this address. In this case, the address exists on a prototype, it exists here, so when I'm asking for a building from an address, I'm changing the building in here. So when a user 2 asks for address and a building, again it goes here to the same object. I hope it makes sense. So it's actually better in this case to do it this way. But the address again has its own prototype, so the function getFullAddress is created only once for the address. So it's a good practice if you're using the prototypal. It's called prototypal inheritance. In JavaScript there is no other inheritance than prototypal, but when you're using the prototypal syntax, it's the best way to do whatever's going to change, whatever is necessary, just put it in the constructor. Whatever is not necessary, just put it outside. If it's not an object, let's not do that with an object, but still works perfectly fine. User1 address should be working. Why it's not working? Okay, user1, where is address? Why is it here? Should be this way. Okay. user1 address, user2 address. Again, because when I'm writing to address, it doesn't exist on its object on its own, so it gets created. When I'm reading, when the user2 is reading from the address, it's reading from the prototype. I hope it makes sense how the prototyping works. And in this case, I'm saving a lot of memory because this gets created only once and it gets assigned a new value only when necessary, when it's actually used, when someone defines an address. This gets created only once. For a billion addresses, this exists only once in a memory instead of billion times in a memory. That's a lot of memory, that's a lot of creation time. The problem here is, of course, with the do contact, because I cannot create privates outside. That doesn't work. It wouldn't work. So if I had the do contact and I would need the closure, I would still have to use this construct. Because I have no way how to create this private outside of the, I need to create the closure around value that should be inaccessible from outside. In this case, it is necessary when you're using the prototypal syntax of creating an object. I hope it makes sense a little bit, even how the objects are actually handled in a memory, how functions can be defined on a prototype of a constructor function, and how it can save memory and execution time of an object. So thanks for watching, and I hope to see you next time. Bronias out.